Hello everyone, this is Maurizio, editor-in-chief of Power Electronics News. I am here at PCIM showing in Nuremberg, and I have the pleasure to be here with Alexander Gerfer, CTO of Würth. Hi Alexander, thanks a lot, welcome aboard.
Thanks for having me, Maurizio. Thanks.
Absolutely, thank you. How is it going?
Fine. First day of the show today. A lot of traffic, a lot of interesting things to see.
Yeah.
And
so,
here now.
Indeed, PCIM. So, tell me what's new from Würth. Which solutions are you showing here today?
Yeah. Again, all about better power inductors. So the MXGI is a new molded power inductor with offering better saturation, less DC resistance in the given packages. So MXGI is one of the topics we show. But anyhow, we also showcase some solutions. We got good feedbacks for standard items like an SMB spacer, which you underestimate sometimes, but makes your life easier in electronic design and mounting later the things, PCB boards and grounding and connecting, right? So we have many things even in the capacitor range, so where we can show a wide range of things for better designs for the future.
Okay, so talking about power electronics, we could also talk about AI. So AI is everywhere, so like power electronics. So what about AI for power electronics from your point of view?
Yeah, so two points, right? Also one point is it for me as a designer, a risk that I lose my job, or can I do a more valued job in the future? And I would say, and we discussed it a bit upfront already, I see if we put it in the right context, if we feed this AI models with the right data sets, we can do things better, faster, as I would do it manually in an Excel file or Excel sheet. Who wants to do all these calculations, double calculations or whatever? It's who wants to do this really, or to analyze given design structures, or even for us, we make magnetics designs, and my dream is the ultimate power inductor design driven by an AI thinking, so how to make it with less material impact. Like when a leaf, you have a leaf, it's not fully structured, you see really structure making the leaf stable and feeding and the green in between and making the rest of photosynthesis. So how would AI then design these core materials, so to say, material-wise, but also in the shape and functional thing to make it best efficient. That would mean so many detailed work in many new formulas eventually I have to create and things I have to analyze in many kind of different depth of analysis things. So, and I can drive it here much more fast in a multi-complex dimension of thing, which I, as a person, would sit there for 2 years or whatever.
Yeah.
And the funny story is I would find then eventually better sweet spots where I say, this I want to analyze in more depth, and that one here. And eventually out of these, I say immediately, with my experience, no, better not, it's too far away. And the manufacturability is then the next topic. But this is already, for any kind of designs, if we bring it in a good quality of data in the systems of AI, with a good, first of all, expert system created, then we can save a lot of, let's say, routine work or very time-consuming work in analyzing things in math or whatever, and make it faster. And then I go for more quality work. I analyze things, I have more choices in a faster time. That's what I see is coming up more and more.
Yeah, indeed, AI can also be involved in how to improve the efficiency, for example, of power electronics design. Efficiency is the watchword in each design, each market. So, do you see in specific market where efficiency is so critical from some point of view? I don't know.
Yeah, if we are honest,
efficiency is
absolutely
it's a must. I mean,
absolutely. We have seen it in the AI discussion with ChatGPT model, and then later on followed by a model coming out of China. How many, let's say, less power you need, but overall it's the same story. We need to have, even in AI, in these data centers, we need more efficiency efficiency means less heating, so better lifetime for the component. So that's what is driving us all, even us as manufacturer for magnetics. We have to find the right solution here. Because 1% saving in a 670 terawatt hours expected for 2030 means 2 million more households could take that energy for driving them a year here in the European Union. So efficiency is really the key driver which needs to be done, which needs new talents, new people also joining the game, engineering teams coming and hopefully seeing that power electronics is the key driver for our future and for saving resources. And that's what we as engineers then can do even better and have to do better.
Yeah, so we need students for power electronics.
We hope, yes, please join us here. It's a very interesting job and you will not get jobless because it's really, power is needed everywhere. Yeah. Any design is somehow powered, if it's micro power or it's really high power, and this is a job we have still there. And
you can use AI algorithm in some ways, but without power on this algorithm probably you
can also not work, absolutely.
Yeah. So, in conclusion, Alexander, so just a roadmap, which is the next, what's next from Würth? So please share some news next.
So one thing is, of course, how to support this idea of bringing more power in a shorter distance on the wafer. We have some solutions which are pending now, we are actively working on. One of the solutions which we are already showcasing is the silicon inductor, also inductor on silicon, which is a more or less clean process, which can be a semiconductor compatible, let's say it this way, for super high switching frequencies and offering then a part for integration, because what can be integrated will be integrated, that's clear. This will not stop. But then you have to have around this inductor new topologies. And again, I need then more engineering teams, engineers, technicians thinking, supported hopefully by AI algorithms, which topology applied to here, to make that then best working. And there will be solutions. We have only to go and to make it. Also what can be integrated will be integrated. That's the key driver for us as well. And then, of course, how to make the components overall more smaller. And a big challenge still.
Yeah, big challenge. Great topic that you shared. Okay. Yeah. Thanks, Alexander.
Thank you very much, Mauricio.
Thanks a lot for your time and have a good show at PCIM.
You too. Thank you very much.
Thank you.
Thanks.